Hi everyone, so we are going to be learning your last section of chapter 9. It's going to be mean absolute deviation. And if you recall, and when we did yesterday, when we went over, I have it here, where do I have it? Here we go. When we did our key ideas, we talked about measures of center, and let's do my mouse. Oops. Oh, it's moving all over here. There we go. Okay. Okay, so we had measures of center, which is the mean, median, and mode. Okay, and then now we learned about measures of variation. So measures of center is when we are working with finding what the center values are of all of our data. Measures of variation is talking about how far our data varies from the least to the greatest. We're not maybe like about our cluster, not so much about our center. So yesterday we learned about range, which is when we did our largest value minus our smallest value. And then we learned about IQR, which is interquartile range, which we did quartile 3 minus quartile 1. All right, and now today we're going to learn about MAD, which is mean absolute deviation. Okay, so let's go to the correct side. So for mean absolute deviation, they usually will say, there's our pen, let's do purple. They usually will say MAD, okay, M-A-D. So there are 4 steps to mean absolute deviation, and it actually goes along with what they're saying. So the first step is to find the mean of the data. So there's that word mean, okay? Next, we're going to find the distance between each data value and the mean. So when they say distance, let's do a different color actually. When they say distance, they're talking about absolute value. Okay, and then when they say find the sum of the distances in step 2, we're going to go over that. And then when it says divide the sum in step 3 by the total number of values, this is saying find the mean again. So if you find the sum of the distance and then dividing, right here is the mean again. And you'll understand how we do the mean twice. Okay, so let's try it. So we're going to do example 1. So let's see if I can get my mouse and go to example 1. Here we go. Okay. All right, so it says find and interpret the mean absolute deviation of the data. What was nice is that they have it in order, okay? However, for mean, we don't really have to have it in order. So we're going to find the mean. Okay, so we are going to do 1 plus 2 plus 2 plus 2 plus 4 plus 4 plus 4 plus 5. So 1, 2, let's count our data. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we're going to divide that by 8. So we're going to get, when we find our sum, it's 24. And we're going to divide it by 8, and we're going to get 3. So 3 is our mean, okay? So I have a dot plot down here at the bottom right. I'm sorry, bottom left. I know I have 2 dot plots, but I have one at the bottom left. And what you're going to do is step 2. And step 2 is you're going to dot. I'm going to do a dot plot first, okay? All right, so we're going to look up our data, and we have 1 above 1. We have 3 2s. You have to make sure that they are nice and neat and spaced out. Then we have 3 4s. So again, make sure they line up. And then we have 1 5. Okay. Now we have to find the distance from the mean. Okay, so we have to find the distance from the mean. And what that means is, I'm going to use a different color. Our mean is 3. So I'm going to go to 3 and box it. Now I'm going to say that this is my mean. Okay, 3 is our mean, which means anything, if I had dots on 3, anything on 3 would represent 0. Okay, because we want to find the distance from each dot from the mean. So what we're going to do is we're going to look at the number 2's, and they are -1, because they're to the left, away from the mean. And then I have this one, -1 away from the mean. And then I have this one, which is -1 away from the mean. And then 1 is -2 away from the mean. When you go to the right, 4 is 1 away from the mean, 1 away from the mean, and 1 away from the mean. Your 5 is 2 away from the mean. It's your distances away, okay? So now when we do distance, you need to do absolute value. And we get to do absolute value for each one, which means this is why we go over to the other number line. We're going to do this again and say 3 is our mean, but now we have to solve all the absolute values. So we know that we had 3 2's, but the absolute value of -1's are 1, and then we have 1 on 1, so it's 2 distances. So this is absolute value of -2, so this is 2. On 4, we have 3 dots, and they are absolute values of 1, so we're going to still do this. And then we have to solve the absolute value of 2, which is 2. And then, step 3, you're going to find the mean of your absolute values. And then that's going to give you your answer. So we're going to do 2 plus 1 plus 1 plus 1. And then I have 3 more 1's. So 1, 1, 1, and then another 2. And we're going to divide it by, we should still have 8. So 2 plus 1 plus 1, all those 1's plus 2 will give you 10. And 10 divided by 8 gives me 1 25/100. Okay? So what that really is telling me, I want to see if I can make this line a little thinner. Let's see. It's okay. All right, so what this is really telling me is that my data values are going to differ. Let's see where I can write this. Data values differ from the mean by an average, which means mean, by an average of 1 25/100. All right, which means if I look down here, here's my mean. It goes 1 25/100 this way, and it goes 1 25/100 this way. Okay, and if you think about it, look where all your cluster is. It's pretty close to right here. So that's pretty good. Okay, that's pretty good to show that our variations are looking where our cluster is. All right, so that is how you find mean absolute deviation.